Alright, here's a little help on your graphing mini assessment since I kept getting a lot of questions. So I decided that I'm going to help you guys solve some of these problems. Number 1 says, below is data collected from a random sample of 80 students regarding their fitness habits. If the entire school set has 600 students, then what is a reasonable estimate for the number of students who consider themselves to have an average fitness habit? Anytime you see estimate or prediction, we are going to be using a proportion. And so we want to know how many consider themselves to be average. Now remember, they only interviewed 80 people, and we're going to use that to make our prediction. So remember, for proportions, we're going to do our part over our whole. In this case, our part is 44 out of our whole of 80. But they want us to make a prediction, so I'm going to use another ratio to predict. If there were a total of 600, that's my new whole, and I want to know what part of that would be average. So remember, proportions, you can try to find a relationship within, or you can cross multiply. I went ahead and simplified that 44 over 80. I divided it by 4, and now I got 11 over 20, and I still kept the x over 600. That just, to me, is a little bit easier to find the relationship now. Now I know that 20 times 30 is 600, so all I would have to do is 11 times 30 to get my answer. On number 2, the hobbies of the teachers in 2 different schools are shown below. Based on the information, which of the following statements is true? So the first thing I did is I added all these up together, and they only interviewed 50 for each one, so the total is 50. Now they're saying, F is saying half of the teachers at West Middle School enjoy cooking and music. So at West Middle School, there's 10 for cooking and 15 for music. So that gives me a total of 25 out of 50. They're saying that's a half, and if I divide both of these by 25, I do get 1/2, so that checks out. And then it says only 30% of the teachers at North Middle School enjoy cooking and music. So at North Middle School, we have 6 and 9, which is 15 out of 50. And your job to tell me is that 30%? Now you know 50 times 2 is 100, so does 15 times 2 give us 30%? And if it does, then F is our answer. Number 2. The number of patients at the doctor's office is tracked over a period of 10 days. Which statement best supports the data? Now with box plots, remember we have our 5-number summary. So we look at 5 main point values. So A says the data for Dr. Amy's office is more symmetrical than the data for Dr. Harris's office. So if we take a look at it, Dr. Amy's, if I cut it right down the middle in my median, then it is pretty symmetric on both sides. But for Dr. Harris, it is not. So yes, this is true. And we could take a look at the other ones. B, the interquartile range of the 2 offices is the same. I know that is not true, because the interquartile range is actually the boxes. So if you look at this one is way bigger than this one, so that's not true. C says the median number of patients at Dr. Harris's office is less than the median number of patients at Dr. Amin's. Well, the median is actually the middle of that box. It's our 3rd value. And for Dr. Harris's office, it's actually more than the median over here, so that's not true. And then D says the range of the data for Dr. Harris's office is less than the range of the data for Dr. Amin's. The range is your actual box plot, the length, and this is way longer than Dr. Amin's, so that's not true either. All right, number 4. 60 students in the freshman class completed a survey about their favorite pet. The pet results are shown in the bar graph below. So I know it's a little hard to see, but there are 28 dogs, and there is 7 for cats. Hamsters is 15, and then fish is 10, and then that does give me a total of 60. So I want to know which one is not true. So F says dogs were the most preferred pet, and that is true. G says the number of freshmen who prefer cats, hamsters, and fish is more than those who prefer dogs. So cats, hamsters, and fish equals 32, which is more than 28. So this is true. H says 1/4 of the freshmen surveyed prefer hamsters. Well, 15 out of 60 prefer hamsters. And if I divide and simplify this, I do get 1/4, so that is true. And then J says the number of freshmen who prefer fish and hamsters is the same as those who prefer dogs. So fish is 10, hamsters is 15, which equals 25, and that is not equal to 28. So J is the one that is not true. All right, number 5. 20 students in Mr. Martin's class each took a survey about the number of minutes they played outside, and we're going to see which statement is best supported by the data. So A says the range of number of minutes outside is the same in the summer and in the winter. Our range goes on our end, so 60 minus 0 is 60. And in the summer, it'll be 90 minus, I'd say about 20, which is 70, and that is not equal to each other, so that's not true. B says the median number of minutes outside in the summer is equal to the maximum number of minutes outside in the winter. Well, the max in the winter is 60, which is right here. And the median, if this is my minimum, my Q1, my medium is this one, and that is equal to each other. So that is true. Number 6. The average number of hours of sleep of Ms. Gambino's and Mr. Zhou's class is shown below. Which of the following statements is best supported by the data? So the median number of hours slept in Ms. Gambino's class is less than the median number of hours in Mr. Zhou's class. Now, median is when you kind of work your way to the middle, so you're scratching off your values like this. So median in Ms. Gambino is 8, and Mr. Zhou's is 7. So Ms. Gambino's class is less than the median. That is not true. It is actually bigger. 8 is bigger than 7. The data for Ms. Gambino's class is symmetrical, while the data for Mr. Zhou's is skewed right. Now, Ms. Gambino's, I would say, is symmetrical, but if Mr. Zhou's class was skewed right, it'd go like this. And right now, this looks a little bit more symmetric to me, so I don't think that's true. H says the range in data of Mr. Zhou's class is less than the range of data in Ms. Gambino's. Well, 10 minus 5 is 5. And Ms. Gambino's class range is 12 minus 5, which is 7. And so that is true. Mr. Zhou's is less than the range of Ms. Gambino's. So we would say H is the answer for that. Number 7, Mrs. Ramirez worked with her personal trainer to help develop a nutrition plan. The circle graph shows the recommended percentages of her daily intake. If she will start week 1 eating 1,800 calories, and how many should be from proteins. So anytime we have proportions, we have our part over our whole. In this case, our total amount of calories that she's going to be eating is 1,800. And we want to know how many of those calories are going to come from protein right here. And I know that she wants 35% to be proteins, and you know our percentages always go over 100. Now I can solve for my proportion on how you want to do this. I automatically see 100 times 18 is 1,800, so I'm going to do 35 times 18 to get my answer. Number 8. The student council is planning for the prom. They have broken down their expenses in the graph below. If they decide they will spend $1,200 on refreshments, so that's my part, then what is their total budget? So just like the other one, I'm going to do my part over my whole. In this case, $1,200 is my part, and I'm looking for my total. My total is always going to be 100%, and for refreshments, it's going to be 30%. So you can go about solving this however you want. Me, personally, I'm just going to go ahead and get rid of those 2 zeros and make it 3 10s. And then I know that 3 times 400 is 1,200. So I'm going to do 10 times 400, which would give me my total. Number 9. Below is the data collected from a random sample of 40 people at the library. If the library has 300 people, then what is a reasonable estimate? Estimate, there we go again, it's a proportion of the number of people who enjoy reading mysteries. So part over whole. People who enjoy reading mysteries is 12 out of 40. If there were 300 people for the total, then how many would be in our part? So it's your job to solve this proportion again. And you can go many different ways about doing this. Me personally, I'm going to go ahead and reduce that first fraction. I'm going to divide both of those by 4. 12 divided by 4 is 3. 40 divided by 4 is 10. And I'm going to keep my x over 300. And then that gives me an easier relationship because 10 times 30 is 300. So I'm going to do 3 times 30 to get my answer. And when you type this in, guys, just type in the numbers. And then last but not least, we have number 10. The circle graph below depicts a breakdown of the way Michael spends his time. About how many hours of sleep does Michael get in 1 week? So we do have hours of sleep. So in this case, I'm sleeping 40% of the time. My apologies, 0 to 2. 40% of the time, and we know percentages always go over 100. So this is my percentages. And I want to know how many hours that is. But I also need to know how many total hours are there in a week. Now I know there's 24 hours in a day. And if there's 7 days a week, then I'm going to multiply that by 7. And I get 168 hours for my total. Now this proportion is a little bit more tricky to solve. So what I'm going to do is I'm just going to cross multiply 168 times 40. Which is 6720, and then I'm going to take that and I'm going to divide it by 100, and that'll give me my answer. And this will be a decimal, and when you solve this, just put in the answer. Alright guys, hope this helps.